In this second module of the course, we're going to shift our attention to some more practical matters. We're going to be focusing on digital audio workstation software, what it is and how to use it, and we'll actually be making music. In this first video, I want to talk about the basics of what digital audio workstations, or DAWs, actually are. And I'm going to focus on some key features that most of them have in common. Multi-track editing and non-destructive editing, automatable mixing, and time synchronization or alignment. So let's start with the basic question of what is a DAW. Basically, it's a software program that sits on your computer that lets you record, edit, and play back multiple tracks of digital audio simultaneously. It's at the heart of most modern recording studios. And it's also at the heart of the tools that most composers and musicians use when they're working with sound digitally, even if they just have a laptop at home. It's the fundamental way to work with and compose with and create with digital audio. You've all probably seen a DAW before. There are hundreds and hundreds of DAW programs out there. There's Reaper, that's the one that we're using in this course. Pro Tools is a professional end one. GarageBand from Apple is something that's included on every new Macintosh that's sold, and also now available on iOS as well. Apple's professional program is called Logic. Cubase is a long-standing one, and Live is a DAW as well that's also sometimes used in live performance. There are, like I said, many, many others. These are just some of the most popular ones to show you, just so you could think if you've actually used or at least seen one of these before. So I want to go through some of the key features that they all have, because pretty much every DAW has a very similar interface and a fairly similar set of features. So once you've learned how to use one, it's very easy to switch to another and another and another. So these are some of the really important things that DAWs do. The first, of course, is multi-track editing. So they let you record many, many tracks of audio and play them back simultaneously. So you can record them one by one. You can sometimes record more than one track at the same time on different audio inputs coming into your computer, and so on and so forth. Most DAWs also let you record MIDI tracks, which is something that we'll look at in Module 3 of this course. Now, why, if you're eventually creating a stereo digital audio file of your song, why would you need to record 4 tracks or 8 tracks or 16 tracks or 64 tracks? Why would you need to do that? It's pretty simple. Once you record audio on a single track, it becomes very difficult to separate sounds that are happening on that track simultaneously. So if you had like an electric guitar and drums playing simultaneously, and you recorded them together on just a single channel, and then you wanted to change the mix a little bit. You wanted to make the drums louder, or you wanted to make the guitar louder, or you wanted to add an effect to just one or the other, or do a separate take of just one or the other, or something like that. That would be extremely difficult to be able to separate the guitar from the drum on that one audio channel you recorded. If you split them out into separate channels in your DAW, then you have a lot of flexibility to edit them and manipulate them independently from each other. And when you're all done editing, you render this down to usually a stereo audio file, or however many channels you're distributing your audio as. So this is why multi-track editing is so important. The next feature I want to talk about is non-destructive editing. And this is really essential to how DAWs operate as well. When you're manipulating things in a DAW interface, when you're moving around audio or cutting and pasting it, splicing it, adding effects, changing the parameters of those effects, anything that you might do within the DAW is not actually changing the audio files that sit on disk. Those remain unchanged. All you're doing is you're kind of saving a description of all the edits that you've made. And then every time you hit play in the DAW, it's actually computing all those edits and rendering them for you to listen to in real time. And the power of this is that any decision you make, you can always go back and change later. It's even more powerful than, say, undo, where you usually have to undo things in a particular order. So if I've done 10 things and then I only want to change number 2 out of those 10 steps, I'd have to undo the 9 things that I did afterwards. You don't have to do that in a DAW. You can change or undo or or rethink any aspect of any of the edits you've made in the environment really at any time. And to really reinforce this point, I wanted to show you the file formats that we're working with in Reaper, the DAW we're using in this course. It's an RPP file, which just stands for Reaper Project. Looks kind of like an HTML or an XML format or something like that. But I want to emphasize this is not a set of amplitude values that are being encoded as zeros and ones on disk. This is some symbolic data that's describing the edits that we've made in our project. And this is just a tiny section of one of these RPP files. But you can see here, we've defined that there's a track that we've placed inside our DAW. It has a name. It's a stereo track because it has 2 channels. And then there's a bunch of other things. And here's an audio item that we've placed onto the track. And there's all kinds of parameters about it. Like, it's fading in and fading out and where it starts in playback and how long it is, things like that. And then we have, eventually here, the source wave file. Where is the original audio data coming from? So this is simply a reference to a file that exists elsewhere on disk. So whenever we make edits, we're not changing this wave file here. We're simply changing all of this information that's encoded as in this text HTML, XML style format in this RPP file. So that's what I mean by non-destructive editing. The next feature I want to talk about is mixing and automation. With each track that we have in our DAW, we have a lot of control to change different properties of that track, similar to what we might do on a mixer, on a physical mixer. In fact, we get in most DAWs a virtual mixer if we want to use it like that. That same functionality is usually replicated to the left of each track that we place in our DAW as well. So this lets us control things like volume. It controls things like panning, left to right of the sound. We can mute a track temporarily so it doesn't play back, or we can solo a track so that all the other tracks will mute. And then we can also add effects individually to channels, and we can control parameters of those effects. This is all stuff that we'll talk about over the course of the subsequent videos in this module. The final feature that I want to talk about is time alignment, which is something that's very important in making music, of course. And DAWs have a lot of features that make this particularly easy for us to do. So you can see this is kind of the track of time as it goes forward horizontally in our DAW interface. We can see measures and beats within those measures, and then subdivisions of a beat there. And then down here is showing this in minutes and seconds and subdivisions of seconds. But if we have lots of different tracks of sound, we want to have an easy way to align the contents of those tracks to this metrical grid, and also, of course, by extension to each other. And so there's a few different techniques that DAWs tend to give us to do that. The first is manual alignment. So we can have a metronome play back, click, 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 while we're recording, to click each beat and indicate each measure for us. So then when we're playing something and recording it in, we can make sure that it's aligned exactly with our tempo and our meter. When we're editing things, similar to what drawing programs usually let you do, we can have them snap to the timing grid when we're dragging them horizontally. So they'll always snap to the nearest beat or the nearest measure, nearest eighth note, or something like that. And if the tempo of something that we've recorded or something that an audio file that we've imported doesn't match the tempo that we've set up for a project, then we usually have the opportunity to manually go in and change or adjust the playback speed of that audio file so that it will match. This can be a kind of tedious process if we're doing it by hand, but most DAWs have the ability to do this automatically using a couple of different techniques. One is through using special audio files that have loop markers encoded in them. The most common file formats for these are recs, recycle files, or ACID files. The ACID files are actually just wave files that have special metadata in the header section of the wave that indicates where all of the beats fall within the audio file and what the tempo is. And so then when a DAW imports this, it can read that metadata and it can decide if it needs to change the playback speed of that audio file in order to match the tempo of your project. And then if you're importing something where there is none of that metadata there, to help you find out where the beats are, well, many DAWs will run an algorithm at that point to try to detect where the beats fall automatically and then make decisions about how to change the playback speed from there. So this all makes it very easy as you're bringing in audio files from a lot of different sources that may have been recorded at different tempos to try to get them to line up together. I want to show you exactly what I mean here for a second. So I'm going to go over to Reaper, and I have a track here set up, and I'm going to go ahead and drag in an audio file here. And this is an acidized wave file, so it has that metadata in it. And so I'm going to drag it up here and let go, and I'm going to turn on the metronome so we can hear how well this lines up. And we'll see we're at 120 beats per minute. And you can hear how that lines up perfectly. Now, this file happened to be recorded at 120 beats per minute, so it didn't actually have to do anything. But if I change my tempo here, say to 76 beats per minute, I drag this file in again, and it's going to automatically look at that header data in the acidized wave file, and it's going to change the playback speed accordingly. So it's still exactly 2 measures long here. And you can see here that it's a little hard to read this here on the video, but it does say here that the original tempo of the file was 120 beats per minute. It says it changed the playback rate to 0.633. That's so that it would match that 120 BPM playback speed. So to quickly review what we've covered in this module, in this video, we've talked about key features that almost every DAW program shares: multi-track editing, non-destructive editing, mixing and automation, and time alignment. In the next video, we're going to get down to the nitty-gritty of how we actually get audio into a project in a DAW program. We'll look at importing and recording audio.